To get started, I'm assuming everyone can hear me. Can one of the panelists just give me a thumbs up? Just let me know if you can hear me. Thank you. My name is Nick Battis. I'm the Director of Exhibitions at Pratt. And I want to thank you all for joining us tonight. And just to let you know, this event's being recorded. We will be taking questions in the chat, so we won't be recording any of the audience members. And I want to tell you briefly about our gallery. We have a brand new gallery on the ground floor of Pratt Manhattan. You just saw one of the pictures of it. You'll see some more in a moment. We moved from the second floor to the ground floor, and renovations finished in July of 2020. And we were in the midst of the pandemic and we couldn't open. We waited about 14 years at that point to get the renovation going and done. And now we had to wait a couple more years. And I'm happy to tell you that as of yesterday, we are able to open our exciting exhibition From Forces to Forms to Pratt faculty, students, and to fully vaccinated pre-registered guests. So if the show is up till April 27th, and if you want to know how you can come in and see the show, please go to our website, www.pratt.edu/exhibitions. We're going to put that in the chat, and you'll find some information about registering there through an Eventbrite link. And there's also a VR tour of the show that you can preview and read all the labels and so forth. And as we get more information, like the recording of this talk, we'll be posting more things to that site. I also wanted to thank the Laser Talks for collaborating with us on this event. We had about 300 people sign up for it, so that was our limit with Zoom. So I have to thank them. I know that most of that is their following. But if you're a Pratt person and found us through our Pratt materials and you don't know about Laser Talks, you could join their mailing list, and we're putting that in the chat as well. And before I pass the microphone on to Ellen Levy, I wanted to acknowledge Pratt's STEAMplant for funding this event. STEAMplant, whose acronym adds the disciplines of art, science, engineering, and math together, has a mission to foster collaboration between the disciplines. Check out their website, also in the chat. So it's been my pleasure to work with Ellen Levy on Forces to Forms. This is the second collaboration that we've had with her. In 2014, she curated the very successful show, Sleuthing the Mind, about art and neuroscience. Ellen's also a multimedia artist and writer, and the past president of the College Art Association. She's published widely and is a recipient of an award from the International Association of Art Critics and an Arts Commission from NASA. She has earned a doctorate on art and neuroscience from the University of Plymouth in the UK and was a distinguished visiting fellow in arts and sciences at Skidmore College. Our exhibition stems from a recent publication that she co-edited with Charissa Terranova, titled Darcy Wentworth Thompson's Generative Influences in Art Design From Forces to Forms. It's available from Bloomsbury Publications. So I'd like to welcome Ellen, who's going to give us a brief overview of the show.
Thank you, Nick. It's such a great privilege to have curated this inaugural exhibition of Pratt Manhattan Gallery's new space. I'm grateful to Nick Battis, director of the Pratt Manhattan Gallery, and to Kirsten Nelson, assistant director of exhibitions, for making the exhibition From Forces to Forms a reality, particularly in light of such extraordinary circumstances we've all experienced. I thank Pratt and also Leonardo for the opportunity to hold this discussion. Here's some background to the exhibition. In March 2021, as Nick had noted, Bloomsbury Press published an anthology that I had co-edited with Charissa and Terranova. The book is Darcy Wentworth Thompson's Generative Influences in Art, Design, and Architecture From Forces to Forms. We've appropriated that last From Forces to Forms as the title for the exhibition. The book enabled a very broad view of the impact of Thompson's original 1917 tome on growth and form, known to many of you who are here. It helped me to understand the continuing grip this book has had on the imagination of many contemporary artists, designers, and architects, from Carolee Schneemann to Todd Seiler. The exhibition, now on view at Pratt Manhattan Gallery, is the fruition of that understanding. Two of today's speakers contributed to our anthology, Bart Kahr and Philip Ball. During the panel, we will explore several themes that recur in the exhibition, such as patterns in nature and complex systems. The exhibition considers the implications of form generation and fosters ecological awareness through a variety of media, from analog to digital, at different scales, from subatomic to macroscopic, and in varied contexts, from prebiotic to ecosystems. Applying knowledge about living forms, a subset of artists exhibits the potential of art to help us restore our dysfunctional ecosystem. It strikes me as particularly fitting that this exhibition be held at Pratt, and here is one reason why. In a chapter of our anthology by architect Sarah Bonmaison, Sarah wrote, quote, "Over the years on growth and form has been a major reference and even a guide for architects." She continued, and now my attention really became riveted because she stated, quote, "In a course taught by Haresh Lalvani, students learned that all volumes could be ordered with numerical characteristics, like a periodic table, an approach very much influenced by Buckminster Fuller. As an aside, so you realize Haresh has two works in this exhibition. Sarah goes on in her chapter to describe his approach to form, in which particular types of polyhedra undergo geometric transformations according to mathematical rules. And these transformations are then organized in a table, and the tables become families of form. To quote Sarah, quote, "As students," and this is at Pratt, "we were surrounded by honeycombs, seashells, photographs of spider webs, and chicken bones. We were trained to link the scientific observation of natural phenomena to art and design education." End of quote. The unusual kinds of questions that Thompson's work provokes are a measure of its far-reaching impact and can be seen also in this show. For example, Stephen Wolfram, another contributor to the anthology, titled his chapter, "Are All Fish the Same Shape If You Stretch Them?" And while referring to food, two of the artists who collaborated, Marta de Menezes and Valerio, asked the question, "What is natural?" Similar inquiries found in all the works in Pratt's show. So do we not become pressed for time, I'm very quickly going to go through the professional installation shots taken by Jason Mandela without much actual comment, and hope you all will see the show. So at this point, I'm going to set up my slides. I'm trying to get this on the full. Let me just raise this. have to move that to and get to the bottom of it. Okay, I'll go through it like this so I don't lose more time. So we start in the larger view here with a view looking in from 14th Street, and we can see Will Lamson's Crystal Growth Project and just a corner of Christy Rupp's piece. These are the names of the 19 artists who are in the show, and there are 3 categories of works consisting of laws of nature, morphogenesis and self-organization, and repairing nature. Next to Will Lamson, which you see directly in front and in front of the window into the street, you will see a collaborative work by Adam Brown and Bob Ruth Bernstein, recreating a famous origin of life experiment of Miller and Urey's. And on the opposite wall, it won't be visible here, but you'll see it later, is Christy Rupp's work. To the right, well, Christy's work is on the right side now, and on the left is the collaborative work of Adam Brown and Bob Ruth Bernstein. So if you continue to the right now of Bob and Adam's work, you will see works of Taube Auerbach. Continuing on, there's a wider view of it. And here you can see you're facing out towards the street. On the left is Christy Rupp's work, and on the right is Auerbach's. And directly in front of you is Will Lamson's crystal installation, which goes on for the duration of the show. Here you see Meredith Trombl's work, which is a wonderful video about photosynthesis. And here is another still from that. To the right of Taube Auerbach's 4 works on the left is a drawing, a wonderful drawing by Todd Seiler, dealing with a fusion fractal reactor. And opposite, you can see his large painting. And again, to the right of the doorway, you'll see Christy Rupp's work. Here are etchings that reward very close scrutiny by Gemma Anderson. And here is close-up. These are etchings. She has devised her own iconography, and it's a very interesting project, which you can get a lot more information on in person. The gallery then opens up to the image you saw Nick show to begin with. And you see Janet Eckelman's sculptural model suspended from the ceiling. And behind it are photographs of what it looks like in life in installation. And at the far left, you can see the collaborative work, which is a taxonomic chart of corn by Marta de Menezes and Maria Antonio Gonzalez Valerio. And here is a close-up of theirs. This is the one that asks, what is natural? On the opposite corner, here we go. On the opposite corner, here you can see works by Lillian Ball, which include not only beautiful etchings, but to the right a game console, which makes it actually quite interactive. Making the transition to another area is this very strong work by Ricky Albenda, and further on, Oliver Larrick, which is the sculptor, in front of a very dynamic line video of his. To the left of that, you will see work by Paul Thomas addressing quantum phenomena, and here is a close-up of it. What is so extraordinary about this piece is that from a distance, it looks like it has infinite depth. Continuing to the rear, let me just go back. You can again see the view towards this third exhibition area, which has work by Maria Elena Gonzalez on the right, who compares birch bark markings to musical scores, and interactive work by Victoria Vesna. And here's some close-ups. This is the augmented reality work, which is part of Victoria Vesna's contribution. And this is the interactive part of it. And the last piece I'm showing here is work by Ursula Endlicher, who will soon be talking about her own work. I suggest that when you have the chance, you virtually guide yourself through the installation. Nick provided a link on chat, but it's also on the Zoom invitation. There is an abundance of descriptive videos and books that accompany the exhibition and reward further exploration. Patricia Olynyk will soon introduce our three main speakers, but let me start by introducing her. She and I co-direct the New York Laser, which is a set of lectures and presentations on art and science projects in support of Leonardo, ISAST. Patricia Olynyk creates photographs, prints, videos, installations that investigate science and technology-related themes and the ways in which social systems and institutional structures shape our understanding of our place in the world. She works across disciplines to develop third culture projects and frequently collaborates with scientists, humanists, programmers, and engineers. She is Florence and Frank Bush Professor of Art, College and Graduate School of Art, Sam Fox School of Design and Visual Arts at Washington University, where she is also affiliate faculty in medical humanities, performing arts, and women, gender, and sexuality studies, and a faculty scholar in the Institute for Public Health and College of Arts and Sciences. Patricia will introduce the main speakers today. Here she is.
Thank you, Ellen, for that very generous introduction, and thank you everyone for coming today. What a real pleasure to be convening again with everyone after such a long hiatus, and Ellen and I are extremely enthusiastic about starting New York Lasers in person again this year, and we are, of course, very, very excited that New York Laser is collaborating with Pratt Manhattan Gallery on this terrific event today. It's my pleasure to announce three speakers in the order that they will be presenting. First is Philip Ball, freelance writer and broadcaster who worked previously for over 20 years as an editor for Nature. He writes regularly in the scientific and popular media, and he has authored many books on the interactions of the sciences, the arts, and also broader culture, including H2O, A Biography of Water, Bright Earth, The Invention of Color, The Beauty of Chemistry, Patterns in Nature, Why the Natural World Looks the Way It Does, The Music Instinct, and Curiosity, How Science Became Interested in Everything. That is a broad series of topics. It's sort of it's wonderful. His book, Critical Mass, won the 2005 Aventis Prize for Science Books. He's a presenter of Science Stories, the BBC Radio 4 series on the history of science, and he is trained as a chemist at the University of Oxford and as a physicist at the University of Bristol. His latest book, Beyond Weird, a survey of what quantum mechanics means, is something that we are all very much looking forward to. Next, we will hear from Bart Kahr, who has been a faculty member at Purdue University, University of Washington, and New York University since 2009. Bart studied chemistry with I.D. Reingold at Middlebury College, with Kurt Mislow at Princeton University, and with J.M. McBride at Yale University. His research group studies complex organized media. Their projects emphasize crystal growth mechanisms, polycrystalline pattern formation, new methods of metrology using polarized light, and the analysis of chiroptical anisotropy. I'm sure I'm butchering that, I'm sorry. He practices the experimental history of chemistry and crystallography. That is, those aspects of the development of a science that can only be informed by contemporary laboratory experiments. In 2014, he was a National Science Foundation Distinguished Lecturer in the Mathematical and Physical Sciences. Last but not in any way least, Ursula Endlicher, a new media and interdisciplinary artist working with interactive media and the internet since the early 90s. Ursula investigates structural components and interfaces of digital and natural networks, and she creates works in contrasting formats, including net art, installation, embodied code-based performance, and often a combination thereof. In her works, humans, machines, nature, and technology interact, often in humorous ways, creating new forms and worlds in between. Thematizing the interplay of digital and natural resources, she uses diverse media and materials, such as environmental real-time data, ceramics, soil, plants, and food, stimulating the audience's conceptual and multisensory perceptions. Her commissions include the Whitney Museum of American Art, turbulence.org. She was awarded an I-Beam residency, and her work has also been shown at the Kronos Art Center in Shanghai, Haus der elektronischen Kunst Basel, Transmedial Berlin, SIGGRAPH, Yokohama, Harvest Works, New York, and the Ujazdowski Castle Center for Contemporary Art in Warsaw, as well as the WK in Vienna. So that's it for the introductions. And I'd just like to remind everyone that we will be taking questions by chat at the end, and Kirsten will be moderating those questions. So without further ado, I turn this over to Philip Ball.
Thank you very much, Patricia. Well, it would have, of course, been lovely to have been able to actually see the exhibition before talking in its context. I'm glad that Ellen has given me at least a little tour of what it contains. It does look fantastic. Let me just now share my screen and see if I can get this running. Here we go. So start the show. Okay, so the how and the why. It's become obvious to me over the years that asking why questions is something that some scientists and some sciences aren't very comfortable doing. You know, that physicists can tell you how atoms came to be and how galaxies came to be, but not why they came to be. It sounds uncomfortably to them like a teleological question. You're asking for what purpose? But asking about purpose is perfectly natural for a biologist. Darwinian natural selection creates a kind of pseudo-teleology to describe which biologists are still struggling to find the best language. Natural selection produces living forms and structures for which it's not only natural but reasonable to ask, what is this for? And that doesn't impute any foresight to the evolutionary process. Rather, it means that shapes, forms, and patterns become selected, and there's a teleological word right at the outset. They become selected because of the benefits they convey for survival and reproductive success. And it's perfectly reasonable, for example, to explain the branched form of the airways of the respiratory system by saying that this form, called a fractal, is an efficient way of distributing liquids or fluids along tubes throughout three-dimensional space. And once we recognize that, we can see that it's no coincidence that that same pattern is found in the blood circulation system and in the roots and branches of trees. Here is a form with a function that is generally useful for solving a common problem in the living world, and so it's no surprise that we see it recurring. But there's a danger that this functional adaptive explanation for living forms can obscure something else. And this is the issue that was highlighted by Darcy Thompson, who we've heard mentioned already in his 1917 book on growth and form, which presented the first synthesis of ideas about shape and form and pattern, both in the living and in the non-living world. Now, in Darcy Thompson's day, Darwin's ideas about natural selection were gaining ascendancy, and biologists, as we now call them, were sometimes rather giddy about its explanatory power. For every question about form and function in nature, it seemed that they could offer the answer, it's adaptive. But there's a deeper question that answer doesn't really get to. And this is what Darcy Thompson was wanting to get at. He's often attributed with the phrase, everything is the way it is because it got to be that way. Now, I've never actually been able to find an origin for this phrase in what Darcy Thompson wrote, but if it is apocryphal, nevertheless, it reflects the spirit of his work. The book's title says it all, On Growth and Form. It's all very well declaring what the adaptive purpose a particular form or shape in the living world might serve, but you still have to make it. In other words, while Darwinism might offer a why, there's still a how to account for, and they are not the same question. Now, I'm going to tell you a cautionary tale about that. When Rudyard Kipling wondered about the zebra's stripes and the leopard spots, he phrased it as a how question. How did that happen? And this was his answer. He said, after a long time, what with standing half in the shade and half out of it, and what with the slippery, slidey shadows of the trees falling on them, the giraffe grew blotchy, and the zebra grew stripy, and the eland and the kudu grew darker, with little wavy grey lines on their backs, like tree bark. And so, though you could hear them and smell them, you could very seldom see them, and then only when you knew precisely where to look. So this is a slightly slippery account in itself because it morphs from a how question into a why question. Having become imprinted with these stripes by the shadows cast by sunlight, the zebra discovered that they were good for concealing him. As a Darwinist would say, the stripes were adaptive. They were for camouflage. And this is generally how biologists and zoologists throughout the 20th century saw it. But there's one problem with these explanations, because this that I'm showing you here is not actually the zebra's normal habitat at all. Rather, it tends to live in spaces like this. So it's not clear what these stripes actually have to do with camouflage. And lots of other ideas have been put forward for why the zebra is striped. Maybe they're illusions to make the animal look bigger. Maybe they're there to dazzle and confuse predators. Or maybe they're a kind of heat regulation. Or perhaps they offer protection from biting insects, owing to the way reflected sunlight from the different areas gets polarized. That sounds like an elaborate idea, but actually there's some experimental support for it. Now, we do suspect that the zebra stripes are adaptive, even if we don't know exactly what they're adaptive for. But if you assume that the zebra stripes are a Darwinian adaptation, that they somehow contribute to the zebra's fitness, then there's apparently no end to the just so stories you can spin about what benefits they can offer. Surprisingly, Darcy Thompson didn't actually have much to say about the zebra stripes. They only appear right at the end of his book on page 1090. All he could really do was to describe rather than explain them. But we now do have what seems to be a very likely explanation. And it was one that was first proposed in 1952 by the British mathematician Alan Turing. He wasn't trying to explain the zebra stripes, actually. He was trying to answer a much more fundamental question in biological growth, which is how pattern formation occurs in the earliest stages of embryo formation in a fertilized egg. And this is a problem that scientists call symmetry breaking. You start off with a more or less spherical ball of identical cells, and somehow these have to become differentiated into those that will form the head or the limbs or the spine and so on. And in Turing's day, no one knew how that happened. Now, the theory he put forward for this was quite complicated and abstract, and it was only in the 1970s that other scientists figured out what the crucial ingredients actually were. Turing had considered not a full developing embryo, but a much simpler system, just consisting of dissolved chemicals that could react with each other and could diffuse around the system, and diffused until they were just uniformly distributed. And he came up with a mathematical model of this system in which patterns could be created by two types of chemical substance that he called morphogens, meaning shape formers. One of them is now known as the activator, because it activates a chemical reaction that generates more of itself. It's autocatalytic. The other morphogen is a substance that interferes with this self-generation of the activator. So in other words, it's an inhibitor. And Turing showed that stationary patterns could arise, that is, persistent differences in the concentrations of the activator and the inhibitor from one part of the system to another, if the inhibitor diffuses more quickly than the activator. And roughly what that means is that you get patches of activator creating itself, but that at some point the blobs that this form can't get closer to one another than a certain distance, because the inhibitor ensures that they're always a minimum distance apart. They can't sort of spread completely. Now, Turing had to do his calculations by hand, so it was hard for him to see exactly what sorts of structures this activator inhibitor scheme might generate. But when computers became available to do that instead, it could be seen that Turing's patterns generate two generic types of patterns: spots and stripes. And Turing himself commented on how these chemical patterns are actually quite reminiscent of animal markings. The idea here is that there are biochemicals that act as activators and inhibitors and during embryo growth, and they diffuse between cells and imprint the skin with patterns that switch on or off pigment-producing genes. And it now seems clear that this does happen in the development of embryos of many animals. So Turing-type models can explain the features of many types of marking. For example, those that are found on wildcats and on ladybirds and on tropical fish and on giraffes. And other kinds of biological pattern can also seemingly arise from these diffusing morphogens during development. For example, the arrangement of the hair follicles on our skin seems to form that way. And even the stripe-like patterns of our digits, of our hands, of our fingers and toes, seem to originate from a kind of stripe-like Turing pattern. But Turing patterns also operate more widely than this. So something analogous to his process seems to account for the stripes of sand ripples that appear in windblown sand. And you can see that there is this striking morphological similarity with the zebra's stripes. And they can be seen, patterns like this can be seen, for example, in microscopic separation of metal alloys and in other inorganic systems. So this mechanism of pattern formation seems to be a universal one, operating at many different scales across the living and the non-living world. And it can be regarded as a generative process. I think Ellen already alluded to generative processes. And that's to say, what is specified isn't the pattern itself, but the rules by which the pattern might arise. Exactly how those rules play out depend on the circumstances, which is why, for example, the same basic Turing process can generate different patterns when it operates on different parts of an animal's body of different shape or different size. And this makes the patterns flexible and adaptive to their circumstances. And it creates a kind of interplay of chance and determinism in how they'll manifest. And those, in my experience, are qualities that seem to attract many artists to generative and algorithmic processes. And here are some examples of those. And I have thoughts about what's going on in these cases and in some of those that Ellen had showed us earlier. But at this point, I want to stop talking and maybe start discussing some of these ideas. Oh, Ellen, I think you're still muted.
Yes, this is so exciting to see. I do have a question for you. I know that many people will have questions accumulating, but I wondered how you first developed the idea of pursuing these kinds of issues. When did you first come across it? for that matter, how did you learn of Darcy Thompson's work
Yeah,
and
well,
of Turing?
that it's going back quite a long way now, Ellen. My first book on pattern formation in nature, I think, was published in 1999, and this was while I was still working as an editor at Nature, the science journal. And I guess, in retrospect, it seems clear that what appealed to me was that this was a topic, a question that cut across the sciences, that wasn't limited to any particular science. And that became apparent to me while working as an editor, that Nature would receive submissions of papers that were reporting pattern formation in many different systems. That there were papers that would be talking about how it happened in zebrafish, for example, or angelfish, and how it might happen in systems of sort of shaken grains that organize themselves into patterns. And so it became clear to me that there seemed to be general principles that were going across the sciences. And having trained as a physicist, I mean, this sounded quite familiar to me because what I had trained in was an area of physics that looks at collective behavior of many body systems. And what those bodies are could be atoms or molecules, but they could be sand grains, or they could be flocking birds. And there are similar behaviors that can appear in all of those systems. So that was a sort of familiar idea to me. And it occurred to me that, this was a kind of a field of research in science in general that would enable me to look at these similarities and these regularities that occurred across the sciences, and that appealed to me very much. And of course, I think I have to say, and I'm sure this is true for anyone who gets interested in this area, the sheer beauty, the sheer visual appeal and of these systems, and the fact that we are surrounded by them. Even here in the study, there are plants in front of me here that show some of the patterns I've been talking about. They are everywhere. So, that's part
and
of
the fact that they're on different scales as well is one of the things that you can see as a refrain throughout the exhibition, that many artists are picking up on these relationships across scales.
Yeah, that's another striking feature. And as I say, that's because when we deal with systems of many bodies, there are rules that govern how they interact, that don't really care whether we're talking at the atomic scale or at the scale of whole organisms or at the scale of microscopic grains. The rules cut across those scales. And in fact, some of the pattern forming systems related to Turing structures, they're generally called reaction diffusion systems, of which Turing patterns are one. These are these are thought to be operating in the patterning on that seashell that I showed at the beginning of my slides. They are also thought to operate or possibly to operate in a sense in the way spiral galaxies form. So you even see these patterns playing out on cosmic scales.
Oh, this is quite wonderful. It's not surprising to me, after all the research I did, that Thompson had a profound effect on the arts and architecture. In a way, what's more surprising is that he still has an influence in the sciences 100 years later. So maybe you could comment on that.
I think it's so interesting how Darcy Thompson's influence has sort of played out over time, because I think it's genuinely agreed, and it seems very clear to me that what he was prescient. He was working before his time. He was trying to answer questions like the questions of the zebra stripes, for which we did not yet have the concepts and the tools, the mathematical tools and the conceptual tools to find answers. So, in some of the questions that he asks in his book about the formation of shells and so on, he could give answers. Others he was still quite puzzled by. So in that sense, he was before his time, although oddly, he was also very much a product of Victorian natural history. And when this is the second edition, which grew incredibly thick, of his book, when it came out in 1942, actually he seemed, completely outmoded. He seemed like he was very much still discoursing in the Victorian manner, in the age of quantum physics. So in some sense, the way he was thinking was left behind. But I think it was really then only in the sort of 1970s, 1980s when we started to have these concepts and also the computational tools to explore them, that people realized that what he was talking about were things that we now talk about as self-organization, and we have frameworks for thermodynamics and non-equilibrium thermodynamics to try to understand them. And so I think there was a kind of resurgence of interest in his ideas from scientists, because they realized that all along that was really what he needed. He just didn't have it in 1917.
Well, this seems like a good moment. We'll have many questions, I'm sure, directed for you about your talk, but it also seems like a good point to bring in the viewpoint of a wonderful chemist, Bart Kahr, and see whether his views on organization and structure mesh. Now, one of the things I always notice is that some of the common experiences that we've had as young artists were the excitement of coming across, for example, Haeckel's depictions of radiolaria with their mineralized skeletons. But Bart Kahr commented in something I read on his surprise at finding that his scientific objects of interest could be found in an art book featuring Haeckel's illustrations. So my question to you, Bart, do you feel that artists and scientists are seeing or conceptualizing things in fundamentally analogous ways or different ways? I wonder if you could speak to that a little bit during your talk.
Sure. The answer, my brief answer to that is absolutely in the same way, just using different tools, and but the questions at their heart are the same, I think, in their essence, and forever have been. Okay, so should I go to my the comments I prepared?
Yes, I saw some of your PowerPoint images, and they seem quite intriguing to raise questions about our ideas of particular structures that are counterintuitive.
Is that?
Yes,
yeah,
we can see it well.
Yeah, so of course, for some people, like the artists in the Pratt show and some scientists and some architects even, the shape of things is enough to get us out of bed in the morning. It keeps us off the streets, and sometimes we'll go to great lengths to seek out things that have unusual shapes. And here's a picture of me pre-COVID when I took a trip to see the largest crystals on planet Earth that are in a cave in Chihuahua, Mexico. And it's a thrilling place, like an underground, all-natural cathedral. I went there with a good friend who I think you met, Ellen, in my office, a professor in Granada, Juan Manuel Garcia Ruiz. We just call him Juanma. And he and I both study in our laboratories how crystals grow. And in any case, Juanma was telling me about a rising theme in anthropology that caught his attention. It turns out that early hominids are often found having been buried with collections of crystals, quartz crystals or calcite crystals or gypsum. And these are crystals that aren't hard enough to be tools. And so the question is, why were they collecting these things? And the hypothesis is they collected them just because they were cool. They were unlike the curvilinear forms of biology. They had straight edges and flat faces, and they were kind of alien. And I said to Juanma, I said, well, then you have to do the experiment. You have to present some monkeys with crystals and see what happens. And he's the kind of genius that doesn't leave any dumb idea unattended. And he says, I'm already doing the experiment. Turns out there's a primate rescue farm outside of Madrid where abused laboratory chimpanzees or circus animals get to live out their senior years in peace. And Juanma was going to present these chimpanzees with crystals and film their reactions. And my son, who's a young aspiring filmmaker, he went over to Spain to monitor the surveillance cameras. And one morning in October, I got from my son Aiden in my email this picture. And this is it, you know, this is humankind reaching for art for the very first time. It was very 2001, but forms and forces, this is the moment. And then they did some other experiments. They gave a collection of 15 stones to one of the chimpanzees. 12 of them were roundish pebbles, but 3 of them were faceted crystals. And the chimpanzee took the collection and went up onto a perch and came back down sometime later empty-handed. And then when my son went up to the perch, he saw this, and this was another morning's email. The 12 rounded stones were separated on the left, and the 3 crystals were separated to the right. And this is, I just thought that this was breathtaking. And it's evidence that, you know, in some ways we're hardwired to be activated by geometry. And geometry can be really alien, and alien things are presumably worth collecting. But in our lab, we've been finding out that crystals are, as they get smaller, even more alien than the polyhedra that we are accustomed to. And you know, the more you think about it, the weirder crystals are. Because why would molecules that can have very weird shapes line up at the points of lattices? Who is telling them to adopt these very regular, translationally related, semi-infinite structures? It's a kind of a military precision that molecules ought not harbor. And we're increasingly finding out that straight crystals don't necessarily want to be straight, but they're artifacts of growth. That is, small crystals have lots of molecules that are living in close quarters and are quite frustrated with one another. And in order to relieve their stress, they frequently undergo global mechanical deformations. So they adopt forms that are more common in biology than in the polyhedral geometrical world of crystals. And, you know, that's why Mies van der Rohe came before Frank Gehry. If you want to build something really big, it's a lot easier to make your components adhere to a lattice than otherwise. And that is part of the reason that New York City has the kind of architecture that it has. It's easy to build lattices. It's hard to build things that give up their translational symmetry. And this is a kind of not a real picture, but in many ways it's a more natural picture, or it's not a picture, it's a collage that I made, but is more consistent with the forms that we understand crystals will prefer if they don't have to grow too big. The reason why the giant crystals in the cave in Mexico are straight is because they're really, really big. And the bigger you are, the straighter you have to be if you want to take advantage of the thermodynamic driving force of growth. Here's another crystal that grows with the helicoidal form. And here, there are lots of crystals that are all packed together, and they're fibrous and they're growing radially. But these telltale markings, which will undoubtedly activate Philip's collective memory of pattern formation, is a telltale signature of the fact that the crystal lattice is twisting as the crystals are growing radially. And this molecule is called, the molecule that's doing this is called deltamethrin. And it's an insecticide. It's the principal compound that we use to combat the Anopheles mosquito that transmits malaria. And of course, whatever I have to say ought to, in some way, reflect upon the art that is in the Pratt show.
Can I ask a question at this point?
Certainly.
In terms of the show, I know that you had been not exactly collaborating, but that some of the ideas Will Lanson has discussed with you as an artist how to affect particular things. And I wondered what your experience had been with Will's work and with other artists who are using crystals.
Well, I have been giving Will sketchy advice for a number of years, and but I think that Will's work with crystals and without is always just so refreshing, and I know that the crystals that are growing in the laboratory right now, I don't know precisely what they are, and I know that we're evolving, they are evolving, but I took as a point of reference from the show, not Will's work, but Janet Egelman's net, a net that is a form-changing fishing net is how it's described. And now, if you're interested in pattern formation, you're already fully convinced that everything is connected. And if you listen to Phil's talk, he made that point very convincingly. Everything is indeed connected. So what does this fishing net have to do with twisted crystals? And the point of connection is this one. Since 2000, the Bill and Melinda Gates Foundation and their partners have distributed more than 2 billion deltamethrin-like insecticide embedded nets, bed nets, to protect against the Anopheles mosquito. And turns out that very often these nets are used for fishing. They are more valuable as fishing nets than as life-saving malaria prophylaxis. But it turns out that the way these nets are supposed to work is all about the forms of crystals. And you might ask, what does a malaria net have to do with crystals? And the way these things work is that the embedded molecules diffuse to the surface of the net fibers and they crystallize. And when mosquitoes walk on the crystals, they absorb the toxicant through their waxy feet, and that's how they perish. And deltamethrin, it takes several hours for it to kill half a population of Anopheles mosquitoes. But since what we do for a living is figure out how to control crystal growth, we have figured out how to get deltamethrin to crystallize in a different arrangement, the same components, but put together in a different way. And now it only takes minutes. And this is very important because these molecules are subject to resistance in rapidly reproducing populations. And so by paying attention to crystal form, we hope to maybe have an impact on the infectious disease transmission, which has been terribly impacted by the disruptions of COVID. That is, combating malaria is you know, it's a hands-on job. You have to go from village to village, and this has all been interrupted during our current crisis. So better tools will be better for all, and crystals have a lot to do with it.
Oh, thank you so much. Wonderful presentation. And I can already see we're getting questions on chat. But first, we will have a talk by Ursula Endlicher. And like the rest of you, I also have a question for her. I'm very intrigued that Ursula has created and cataloged an entire group of forms and making a translation from the analog to digital and back again. I would ask her if she could pursue some of the implications of these hybrid forms. What do they mean to you, Ursula? The floor is yours. You're muted. Ursula, you're muted.
Sorry, muted and trying to share my screen. Too many tasks at once. Let me try. Give me 1 second. If it lets me. It lets me. So, thank you, Ellen, and everyone. I'm really thrilled to be here. I see so many familiar names and faces in the audience. It is really, I'm really happy. It's great. I'm also really intrigued about the show and about your questions. So let me talk about this vocabulary, maybe by demonstrating a little bit about it, how I basically arrived there, and what I basically do in the piece that is in the exhibition is that I try to build an interface for the web that has the quality of vegetables. And so let me start from the beginning, where actually, when I went through the exhibition, virtually, but also I've been a few times in the gallery installing, I was really intrigued by the variety of approaches, of hybrid approaches, I should say, how the artists actually where came up with ideas for forms, for organization, for blending, ideas of nature with, let's say, there's ideas, the living, the non-living, the board of natural and unnatural, and analog and digital. And it is a really enriching experience to go through the exhibition. So, but let me jump in. What for me, where my background is really between the internet technologies and the performative performance and also the visual arts. But I've been for a few years now I started building works that actually reflect on the environment and on nature. And so I try to basically, when I talk about this piece now that is in the exhibition, there are like 3 areas that kind of help go through the idea, and it's the idea of the interface. And I used a morphological approach to come up with this interfacing between the natural and the digital. And interaction is another way of thinking about how this actually might work. So as a precursor to the piece is called Input Field Reversal, was a series of outdoor installation called Input Field Form. And in my practice, what I like to do is I actually I think of my practice often as like a conceptual augmentation of different disciplines, and so what I try to do is basically I'm superimposing network structures from nature and from mostly the internet and internet network processes to see if there is a relation between, because translation for me is also very often see what are the what do systems have in common, and what are those kind of similarities where actually translation could communication could actually happen. So I try to embed user interfaces like application forms into the environment, and basically translating like a whole so-called input field from the HTML language into a field, trying to resolve questions of functionalities, online functionalities, and see if I can come up with an answer in nature. So one approach was to look at morphology and how those fields actually, what those online fields ask a user to do. So for instance, an email field has the @ symbol as this marker that is always part of the email address. And for me, I thought, well, actually wonderfully, the @ symbol finds like a correlation in nature, maybe with the kohlrabi. Like it has a very similar shape with this inner bulb and like this swirling arms around. So I thought, well, there's a correlation from two totally different fields and disciplines. So playing with thoughts like that, I could also plant the garden. But other questions that were raised was really, actually, what kind of communication do plants have, right? When we talk about communication, then plants talk through their root system, they send chemical signals, and basically there's the practice of companion planting that shows also how plants actually grow better together in a polyculture. And thinking about ideas like this for an interface online seem to be actually very valuable. Other ideas of like data collection and what to do with data as an output was translated into the harvest of the field that was actually put onto a grill and offered as edible HTML to visitors. So it was actually a very hospitable system, promoting stewardship and care and the participatory, offering also food to the guests. and actually opening up a conversation about networks, internet, natural networks, networks in technology and in nature. So taking this whole conversational and research part that into a next step, I was invited to a residency at Marble House Project in Vermont, where I found a beautiful, luscious vegetable garden already on location. And for me, that was the initiator to think actually of translating now a structure that was already found into like an interface for the web. And how my thought process started was to think actually about the different vegetables that were planted and how I would be able to build interfaces for representing those vegetables. And again, like a simple, very simple morphological approach to natural with digital came in handy, thinking about the potato, that when potatoes sprout, I found a parallel that actually also like a web-based native pull-down menu kind of unfolds. So this kind of analogy of this unfolding could be used for an interface, and the eye and the potato really match the little arrows in this interface. So this was a way of thinking about how I could shape something so absolutely the opposite from a potato that lives online into a shape that would actually go in a direction of a vegetable. But I also, of course, I thought about plant characteristics and behavior. And I had a lot of research into plant growth and plant behavior, how plants behave during environmental changes. And also this would be used, how I would build a digital interface that actually would change with the weather. And also the growing mechanisms of the biological plants were basically written into algorithms to match the behavior of the digital plants.
This prompts a question from me, Ursula. For example, do you see what you are doing as connected with a conservation kind of mind? That one of the things I note among a number of artists, some in the show, is that there is a real interest right now in taxonomy. In the exhibition, I see this with Marta Jimenez's and Maria Gonzalez Valerio's work, with Gemma Anderson's work, Paul Thomas, Christy Rupp, who has actually applied art historical practices of organization, reproduction, collection, and arrangement to address why our impact on nature has often been negative. So many of the artists are involved with a kind of reshuffling of taxonomic categories. Mm-hmm. Do you relate to that kind of thinking? Is that an interest?
Yes, absolutely. And this is really where also what I like to talk about. So for me, and that answers your question about those taxonomic ideas also. I created also actually in the element, in the HTML language, tags that would represent those vegetables in the online piece. And in my work, I am interested in bringing together the digital and the natural, and building this interface, kind of behaving in a way like a plant, like a potato, opened really up, building a more building like a sentient interface, really opened up a way into thinking beyond the digital, like when you actually surf the web. And so I'm interested in building hybrid forms that really connect the natural with the digital and alert to it, because this interface also changes by environmental changes. So it actually affects how this interface looks, and that way you are connected to your environmental surrounding.
There's also very much an interactive element. The user of your work basically is filling out forms and making the connection between what they are eating and how it is described. So I think that is something that's very much in the air and certainly in your work. I'm sure did you want to continue, or do you think this is a good point maybe to open this up to questions from the other people who've spoken as well as the attendees of the Zoom today?
I absolutely can see this as a good point. I want to answer also very briefly your question, like which artists I see like a relationship, a kinship with, and I definitely could see this with Gemma Anderson's concept of the isomorphology, and just very briefly, I'm building also this kind of taxonomies, connecting the HTML language with actually categories in nature. And Gemma really does this, I think, in her isomorphology as well, when she has a drawing technique and finds like really resemblances also with animal, like in animal and vegetable and minerals, and her drawings are very much based on this, finding this parallel, and I find a real kinship to her work there. But let's open. I can stop here and.
Well, I think what you're speaking to is the fact that so many of the works in the show are testifying to a new kind of view of evolution, one which is more lateral and horizontal than a vertical descent. So, Kirsten, would you like to read from some of the questions we've received?
Sure. I'm going to start out with a question from kind of earlier on in the talk, reference to Philip. But I think this is something that everyone may actually have kind of an interest in. So patterns apply to social sciences too, right? So I'm wondering if you could comment on the balance of the familiar and unfamiliar, regular, irregular, in the sense the edge of the familiar, not as far away to lose connection. The idea that the property of the mind is to create intention. So the question was directed towards Philip, but if others after would like to respond as well. If you need clarification, let me know.
Thanks. Well, first of all, in terms of the general context, the fact that patterns appear in the social sciences, they absolutely do. Some of these same patterns do. In fact, my book, Critical Mass, looks at how some of these ideas apply to social systems. And for example, even Turing patterns have been proposed as cropping up in the way crime is distributed, that crime creates more of itself, but if you have a force that is suppressing it, that acts as an inhibitor, and you can see a kind of Turing-like structure arising. So it's incredible how they do appear. This notion of this balance between familiar and unfamiliar, I mean, that to me, that sounds like a different thing, but a very interesting one, because it's certainly a very well attested phenomenon for the human mind that we seem when we think about what we prefer in terms of complexity of a system, that actually there is that balance absolutely in many different contexts. You see it, for example, in people's musical preferences, in preferences for visual art, that it seems that, you know, we look for a sweet spot between simple structures and patterns that we can easily spot, but in the end they're too easy to spot. You know, in music it becomes like listening to nursery rhymes, and complex structures that excite our pattern forming sort of instinct, really. I think it is an instinct, our pattern spotting instinct, I should say, but that if it gets too complex, we simply can't make out a pattern. We lose it, and in fact we lose interest there. And so it seems that, for example, in music there's a clear tendency for people's preferences to follow a sort of U-shaped curve when you think about how popular something is against how complex it is. There is this sweet spot. So, you know, whether, I mean, that's certainly saying something, I suspect, about the processing power that our minds intrinsically have, that actually, you know, we can't deal with too much, but also that actually we are somehow seemingly programmed to look for things that aren't too easy, that aren't too transparent, that have the right amount of complexity to just capture our interest and perhaps excite our imaginations.
Would anybody else like to chime in on that or ask a related question? Ursula, I do have a question for you. Do you see what you're doing as in any way changing or influencing people's behavior, becoming or basically promoting awareness of the foods they eat and the relationship to the structures of culture and society that they've set up?
Yes, of course. I mean, that's a very good point. So building like an interface that has like a sentient quality is really the opposite to how you would normally interact online, where any interface would be more about being quick and delivering, going quickly to a different location. You can buy things. So my piece actually promotes that you stand back, that you basically, you have to interact like you would have to interact with a plant. So you're very careful, very slowly. And so in this way, I could totally see that. And I also, my works that where I invite audiences into the gardens, those are works where one is really in nature, where you are, food is served. So those invite for communication about these topics. And so that way, really a conversation about networks comes up and also can be discussed.
Well, with so many of the works that I see in the exhibition, I think of that famous poem which features real frogs in imaginary gardens, or maybe the reverse, imaginary gardens with real frogs. But I see worlds being shaped, created on a range of scales with different kinds of potential in this very fraught age that we live in. Nick, perhaps you were running towards the end of our time. Would you like to say a few comments?
I would just like to remind people how they could come and see the show, but I think we could take a few more questions afterwards. If you came in late and you didn't hear earlier, the gallery is now open to visitors. Pratt students and faculty can come during gallery hours, which is Monday through Friday, 11 to 5. And visitors that are external guests can register through our website, www.pratt.edu/exhibitions. You'll find an Eventbrite link there. And if you're vaccinated, you can register and 24 hours in advance to come and see the show. So also that we will be posting the recording of this talk to our website and other venues, YouTube and Laser Talks.
And if we have a bit more time, I'm seeing quite a number of questions in the chat that we might want to try to get to Stephen Nolan and Greg Garvey, and maybe some above that, Kirsten.
Yeah, I was actually just about to pull out Stephen Nolan's question, which, I think, and it's to all the speakers. So art has inclined over the past century plus to more objective criteria in lieu of traditional subjective criteria in directing form and shaping artists' expression. Artists gravitating to science, it seems like a contemporary manifestation. So the panelists, do you see this historic arc as reflecting a broader change, or do you see something else that's driving it in the kind of current time? Does anyone want to take a shot at that?
I'll give it a shot. If I understand the question correctly. I mean, I guess partly I have a question about criteria for what is this a question about how the art is judged, and that a notion that there are some objective criteria by which we can assess it? Because if so, it's certainly a very interesting discussion to have, because I guess this is where we get into questions about what neuroscience can tell us about how art is perceived, and there almost seems to be an aspect to asking those questions of asking whether the art is being perceived correctly or not, which is a very controversial way to think about how it's being perceived. But certainly, I guess it touches on E.O. Wilson's notion of, he wrote a book called Consilience, which was trying to bring in a sort of neuroscientific and evolutionary biological perspective on how we understand and perceive art. And his position was that at root, the responses we have to be ones that have evolved for some reason. And again, thinking about music, as an example, that this is, there's been a big discussion about whether music is inherently adaptive, because all human cultures seem to have it, or whether, as Steven Pinker had suggested, it's kind of parasitic on other mental capabilities, cognitive capabilities that we had developed and evolved for other reasons, and music just happens to make use of them. Sometimes, these sorts of discussions, and certainly in that case, these discussions can seem to be almost a sort of become a proxy for discussing whether there is intrinsic value in the art or not. And I think that that leads us into some of the sort of controversies that have surrounded it. I think personally, I think that's the wrong way to look at it. I think that certainly when we think about why we have a response to music, ultimately, it seems to me that it is playing with our pattern-seeking instinct that we do have as an adaptive capability, but the music is literally finding ways to play with that. I mean, I noticed that Greg Garvey's question here actually touches on that too, because he's talking about Leonard Mayer's ideas about music, and which drew on the notion that actually what's happening is that our emotional response to music comes from a sort of frustration of our expectations that our pattern-seeking systems have given us. So that's, and I think that's a really interesting perspective, that actually perhaps it seems to me what the arts are sometimes doing is doing that, is playing with those kind of instinctive responses, and particularly the one we have for seeking pattern and seeing form and regularity, and somehow sometimes subverting that in order to create an emotional response.
Thank you. I think that's wonderful.
I just also, I like the question, like asking if basically that artists are gravitating to science more. And I mean, science and technology are part of more of our daily life, and that has definitely changed. And so therefore artists also will reflect more on science and technology in their work, and so that's definitely, I would say, a broader also ontological reason why that has happened.
One of the comments of Ursula's that will forever stay with me now is likening the @ sign on the computer to the shape of kohlrabi. I think that's marvelous. Unless there are some pressing questions, we are at the limit now. But let me summarize a little bit of what we're talking about here. The exhibition explored several themes that recur, including, as we've discussed, patterns in nature, emergence, complex systems, and even relationships between the animate and inanimate. So the questions that become raised: how do artists tap powerful yet unseen forces through emergence? And how can we direct these forces to come into a better synchronicity with nature? How might artists intersect the virtual and real worlds in ways that illuminate both? Can art help us affect needed environmental change through identifying patterns of behavior? This is something I see operative again throughout the show, and it's very pertinent to Victoria Vesna's work. But also looking at those invisible worlds, which Paul Thomas does in his presenting his understanding of quantum physics. It helps us really give a relationship to forces that are present with us, but generally unseen. And these are very stormy times. I thank each and every one of you for attending. I thank the speakers. And once again, I thank the hosts, Leonardo and Pratt and Nick and Kirsten, for the incredible job they did in installing this remarkable exhibition. And to my co-director and friend, Patricia Olynyk. So thanks so much.
Thanks, everyone.
Good night, all, and thank you to the artists that I saw that joined us tonight that are also in the exhibition for lending your work and being part of it. Bye.